This is something that honestly took me a little bit of time to fully comprehend. Our gut harbors a complex community of over 100 trillion microbial cells. It also has the highest concentration of immune cells inside the entire body. One of the main roles of the immune system is to attack and neutralize microbial species like the bacteria inside of our gastrointestinal tract. So how in the world does the immune system know not to attack beneficial bacteria within the gastrointestinal tract? Because most people tolerate their gut bacteria fine. But if for some reason your immune system decides that the bacteria inside of your intestinal tract are not friendly and they need to mount an inflammatory response to them, this could lead to the development of things like IBD, colitis, and Crohn's disease. The answer appears to be a specific molecule called butyrate. Butyrate is a short-chain fatty acid produced when the gut microbiome ferments fiber. It is secreted in the highest amounts by commensal or beneficial bacteria. And butyrate actually has the capacity to bind to immune cells and not only decrease their activity, but increase their production of a molecule called IL-10, which is an anti-inflammatory immunosuppressing molecule. And if you knock out the production of IL-10 in mice, they very, very rapidly develop irritable bowel disease and many other issues associated with an increase in immune system activation within the gastrointestinal tract. Butyrate almost acts like a signaling molecule to tell the immune system within the gut that we have the right ratio of beneficial to non-beneficial bacteria within the intestinal tract. And low levels of butyrate-producing bacteria actually increases the activity of the immune system within the intestinal tract, which will kill off the gut bacteria until the right balance of butyrate-producing bacteria is restored. Which means if there is high enough levels of butyrate, the immune system calms down. But if there is not enough butyrate, the immune system will become more active and essentially try and kill off the bacteria within the intestinal tract in order to make room for more butyrate-producing bacteria. But if for some reason we are not consuming adequate amounts of dietary fiber, we are not giving these butyrate-producing bacteria the necessary fuel they need to survive, meaning we will maintain a chronically elevated immune response. But in the absence of dietary fiber, we will not see a rebalance of butyrate-producing bacteria, because we are not providing the necessary substrate for these bacteria to actually survive and proliferate. And this appears why, while dietary fiber is essentially an inert, indigestible substance, it appears to be one of the most anti-inflammatory components of the diet, because it can feed butyrate-producing bacteria, increase the production of butyrate, and this butyrate will have a meeting with our immune cells and tell them it's time to chill out.